So our aim today is 9.7 trig ratios and inverse trig functions. So by way of reminder, the 6 trig ratios are sine, cosine, and tangent, and their reciprocals cosecant, secant, and cotangent. Now, if you remember the mnemonic, all students take calculus. All 6 trig functions are positive in the first quadrant, while sine and cosecant are positive in the second. In the third quadrant, since both x's and y's are negative, that would make tangent and cotangent positive because it's sine over cosine or y over x. And in the fourth quadrant, cosine and secant are positive. Notice how the x values are positive. So let's look here. We have that cotangent of theta is equal to -4/5, and that theta is in quadrant 2. So we need to find the exact value of secant in simplest radical form using a rational denominator. So the first thing that you want to do here is you want to construct a right triangle on a Cartesian plane with theta in standard position. It could look something like this. Notice here that we've constructed it in the second quadrant as per the directions. Now, when it comes to determining which will be negative, will it be -4 or -5, we have to think about the quadrant. So since cotangent is adjacent over opposite, and it's negative in this quadrant too, that would mean that our x value here would be negative because our y values, or the opposite side, would always be positive in the second quadrant. So the adjacent side is -4, while the opposite side is +5. So now we have to find the length of the missing side. And here, since this is a right triangle, we can use the Pythagorean theorem. -4 squared plus π squared is equal to c squared. And so c is equal to the square root of 41. We exclude the negative because we're talking about a length. So now that we know that the third side is the square root of 41, we know that the ratio for secant of theta is hypotenuse over adjacent. So that would be the square root of 41 divided by -4. If we had a radical in our denominator, we would have to rationalize our denominator. So now, how can we determine theta? Here's an example. In triangle PQR, the measure of R is 90 degrees, so we have a right triangle. RP is 57 feet, and QR is 93 feet. Find the measure of angle P to the nearest tenth of a degree. So now we have to determine the known sides that correspond to sine, cosine, and tangent. So we're going to draw and label a right triangle, as would be right here. And based on what we've been given here, if we have the opposite side and we have an adjacent side that have been drawn. Therefore, with that information, we can determine that we'll be using tangent. Now, notice here, to find the missing angle, we would use the inverse trig ratios known as arcsine, arccosine, and arctangent. You can think of it as working backwards from a problem where you're given the ratio but not the angle. The arcsines help you to determine what the missing angle would be. And notice, though, that that -1 does not mean that we place it as a fraction. That -1 is not to be considered an exponent. So now, with that problem, we know that tangent of P is equal to 93 over 57. So if we incorporate an arctangent on both sides, what you'll notice that happens on the left is that the arctangent and the tangent actually cancel out because they are inverse operations, leaving P. And we get that P is equal to arctangent 93 over 57. And so now, in order to determine what P is, make sure that your calculator is set to degrees, and you're going to hit second tan, because just above your tangent button, you'll see the arctangent function. And when we get this, we round to the appropriate degree, or the appropriate place value, in this case to the nearest tenth of a degree, and so we get that P is approximately 58.5 degrees. Your homework today is Delta Math. Scrap paper is required, and please take note of the special due date time. It's not 3 p.m. as usual. Take care and have a good day. Bye.